What's up, math scholars? Today is geometric sequences when they have a constant multiplier between each term. Unlike yesterday when they had a constant slope and a constant number they were adding each time, we're going to be multiplying. And that causes the numbers to get really big really fast. Exponential growth. Can I see exponential growth with your arms real quick? Do you remember? Garrett's decided should you go like this or this? What do you guys think? Growing. So starting low and ending high. Good job. All right, who's excited? Last section of the chapter. Woo! All right, so let's start. I'm going to do what I did yesterday, and I'm just going to highlight what you should write down from each of these slides. Let me get my highlighter. A geometric sequence is a sequence where the ratio of any term to the previous term is constant. So actually, that's kind of a wordy explanation. I would just jot down that geometric sequences have a common ratio, and that common ratio is how much they're multiplying by each time. So there you go. Common ratio is multiplied, unlike slopes when they were added. So did you get a chance to peek at this ratio, or this sequence 5, 10, 20, 40? I think we even saw that sequence yesterday. Are they adding a constant amount each time or multiplying by a constant amount each time? And what are they multiplying by? So instead of calling it a D, yesterday we called it a D for a common difference. Today we call it R for a constant ratio. So our R value would be a 2 in that sequence. So we're going to look at these two sequences here at the bottom, figure out whether it's geometric. So it will be geometric if there's that constant multiplier, the common ratio. What do you guys think about number 1? Is 36 times 3 108? You just want to check that. Yep. So I would say yes, it is geometric. There is that constant ratio, or that constant multiplier of 3. Good job. Oh, they just said find the next two terms. We better do 108 times 3, which is what? You have your calculators by you, right? Do 108 times 3. Did you get 324? Good. And then do 324 times 3. What'd you get? Good job. Okay, so here's number 1. Now, kind of yesterday, you know how sometimes our common difference was a positive number and sometimes our common difference was a negative number? The same thing will happen today. Sometimes your constant multiplier might be just a regular positive number. Sometimes your constant multiplier could be a negative number. And guess what? Sometimes your constant multiplier could actually be a fraction. And that's what's happening here. Does anybody know what fraction they might be multiplying by? Close. It's not 4. I heard somebody say it. It's 1/4. Yeah, 1/4. I for sure heard 1 or 2 people say 1/4, but I for sure heard 1 or 2 people say 4. So I'm just saying. So 1/4 is your constant multiplier. So that means yes, it's geometric. What would be our next two terms? What's 4 times 1/4? And then what is 1 times 1/4? Can you do that in your head? 1/4. 0.25. If you want to do fractions, you can go with 0.25. Yep. All right, good news. We have another formula of the day. So go ahead and write down what I have in the highlighter region here. That's the formula of the day for a geometric sequence. Now, what would you guess that A1 is going to stand for today? The first term, just like it stood for that yesterday. So A1 means the same thing as it did yesterday. A1 sauce. And then the R, that's new for today. That stands for that common ratio, or the constant multiplier that we found in the last couple slides. So I'm going to put that up. All right, we are back. We want to write a rule using the formula of the day for this geometric sequence. So we need to identify two things, our first term and our R value. What's the first term? Good, I'm going to jot that down as my A1. And then what is our constant multiplier? 3, good job. So let's use the formula of the day. It's our job to put in a number right here and right here. So here goes. A1 is 4. The R is 3. You don't need parentheses around the 3. If you want to put the parentheses, that's okay. I normally don't unless it's a fraction. And then n minus 1 is all as a power. So make sure when you're writing n minus 1, you write it all small. I have people that write their powers too big, and if you write your power too big, it looks like a regular number. Question? Some people are asking, how do we want to find the 10th term? Can't we just multiply by 10 or multiply by 3 10 times? You absolutely can. Or you can use the formula. That's why we have this formula of the day. So here's how you can do it easier and quicker than hitting enter 10 times. Just do 4 times 3 to the 10 minus 1 power. 4 times 3 to the 9th power. I think it's going to be a big number. These sequences grow really fast.
Oh, yeah.
What'd you get? Let me take it in.
I'll tell you what I got.
What'd you get?
78,732.
Yeah, I mean, this is exponential growth right before you marry us. Wouldn't you like it if your bank account was growing that much? Like tripling every day?
No,
Your bank account was tripling every day, but you'd be doing good, huh? This time we're going to write a rule. That means use the formula of the day again for the nth term of this geometric sequence. All right. Well, we need to identify 2 things again. The first number is 256. Very good, right? And the constant multiplier. It's a little bit harder to figure out. Oh, yeah. It's just a 1/4. Hey, Ken brought up a good point. He goes, wouldn't this constant multiplier be negative? Let me take a second, pause what we're doing, and show you a sequence with a negative constant multiplier. I'm going to have my sequence start off at 1, and I'm going to have my constant multiplier be a -2. You're going to see what happens. It's pretty cool. Alright, so sorry for the pause, but I think this would be a good learning moment because something Ken said. Ken was talking about what a negative constant multiplier would look like. What is my first term in the sequence? 1. Yes. What's the constant multiplier in the sequence that's taking me from term to term? Now visually, look what's happening. Positive term, negative term, positive term, negative term, positive term, negative term. That's what a negative multiplier does. Isn't that cool? So we do not have a negative multiplier on this one. We have a fractional multiplier, and that's what causes shrinking and exponential decay, we call it. Make exponential decay with your arms real quick. Shrink it down. Now don't let your arm drop too low. This arm always stays up in quadrant 1 and 2. We never go down below the axis. What is preventing us from going down below the axis? Asymptote. Good memory. All right, let's read our formula out. Formula of the day. A1, 256. R, 1/4. Now this is where you would want to use the parentheses on the calculator. And then the exponent and -1. Hey, I want everybody all by themselves on their calculator to find me A50, the 50th term of the sequence. Find the 50th term of the sequence all by yourself on the calculator. You're probably looking at your calculator screen right now going, what the heck? So are you guys seeing 8.077, I'm going to round that, E, -28? Have you ever seen that capital E before?
Yeah. Remember I brought it up in class.
All right, so we were chatting about this capital E and what the meaning behind it is. That's something you need to be familiar with. What that capital E means is times 10 to the -28. So that's actually how you would write it in a paper. If you just write E -28 in your paper, it's going to be evident that you don't really know what you're talking about. So you're going to go times 10 to the -28. Okay?
Do you understand that, Garrett?
Were you listening?
Okay. Totally.
Number 5. Find the 15th term in the geometric sequence below. We need a plan. Anybody have a plan? Yeah?
So E just means times 10?
Yeah.
Okay, sorry.
Yeah, it's okay. What's the plan, Ray?
First number is going to be 15.
Okay.
R is in the parentheses.
Okay. He was kind of blurting and taking your spotlight away from you. But do you know how he got 2.5 as his multiplier?
How did I get it? No, I did not multiply.
I work backwards is what I do. What did you do, Ken?
I divided.
Take the second term, divide it by the first term. That'll get you the multiplier. So 37.5 divided by 5. The constant multiplier is a 2.5. He was right. All right, let's write the formula out. 15 goes first, then your 2.5, then your n minus 1. All right. All by yourself, find the 15th term for me. Stay in your calculator. Find the 15th term.
Wait, but with this one, do we have to put the 5 and 4? Oh, yeah.
It's pretty big. It's really big. It's not in scientific
I
notation.
got 5, 8, 7, 9, 3, 5.448.
I just rounded it, but yeah, it's really big. Exponentially growing, right? They're requesting board buddies, so why not? Let's do board buddies part A. Hey people in the video, we had a bunch of board buddies come up and it was just fun listening to the conversation. I was hearing people go, you need to write the formula, you need to do this, you need to do that. Let's read the instructions. Why don't we? You know, that's always a good life skill, reading instructions. Tell whether the sequence is arithmetic or geometric. That's a fancy way of saying, are they adding a constant amount or multiplying a constant amount? And then write the next term. You shouldn't need a fancy formula to write the next term, right? You're just summarizing the pattern. What is the pattern here, since nobody wrote on the smartboard?
3, 6, 9.
They're adding 3 each time, so that means arithmetic when they add the constant amount each time. And what would the next term be?
18.
That's all you needed. Why would you need a formula for that, you know? All right, we're going to go on pause and do board buddies on the next one.
Have you seen this story?
Hey, you know one characteristic of math scholars? They come up with good memory tricks to help them remember things. And Kaylee was back, Alyssa was back there going, A for add, A for add. Arithmetic is added. Geometric is multiplying. There's not a super good memory trick for that, but they are multiplying by a half. That's why your numbers are shrinking. And the next term would be 4. So we're on the video. We kind of already did ones like this. This just talks about how a linear regression line would be an arithmetic sequence, and an exponential regression line would be a geometric sequence. You can actually use Stat World to help you. So let's end the day with a couple Stat World problems. Okay, so I'm looking at this. You have to make a guess before you head to Stat World. You have to guess, do I think it's arithmetic or geometric? But you can use Stat World to help you explore whether you were right or wrong. Ken, what's your guess? My guess would also be geometric because of just how small the numbers are getting quickly, okay? So let's get into Stat World and put these numbers in. Stat, edit. I'm going to clear my old numbers by going up top and hitting clear. You never want to go up top and hit delete, or you'll delete your L1 and your L2. So we have our second term, we have our fourth term, and we have our seventh term. Oops, I messed up. I am, but they're calling it second, fourth, and seventh. So I'm putting in 2, 4, and 7. Does that make sense? They use words to describe what term it was. And then over here, a 2, a 0.5, and a 0.0625. There's a 5 there on the end. My calculator blocks the data. It's kind of annoying. There we go.
Ooh.
247, 2.5.0625. I thought it was triple check. All these are inputted correctly.
Oh, I didn't see the 5. You gotta cover it up.
I know, the calculator's always kind of in the way. Ken's guess was geometric, so it's just a guess. So when you do your stat edit, stat calculate, what choice are we going to choose for geometric? It's exponential. Geometric is exponential, so it's choice 0. If your guess had been arithmetic, then it would be choice 4. Let's see, we'll find out real quick if we have a good R value and whether it's a good fit. Stat, calculate 0. Look at that R value. It's exactly on -1, so it's a perfect fit. Geometric would be choice 0. Arithmetic would be linear, so it would be choice 4. But let me write out the formula it just gave me. 8 was the starting amount, so that would be A1. And B would be 0.5, so that'd be the constant multiplier. She's just observing. Which is why I can hear that. Hey, I just had a moment that I realized the calculator gives you an exponent of just an x. So the calculator is working off of term 0, not term 1. And I kind of filled out the chart to show you what I meant. If I would work one term back from the second term, I'd get the first term, that'd be 4. If I go back one term beyond that, that'd be an 8. So this is actually the 0th term. Okay, I'm gonna sneeze.
Bless you.
It's not coming. Right, the first term, the 10th term. So if we wanted the 10th term, you just kind of want to think 7, 8, 9, 10. You can just keep doing your multiplying. Or I guess you could put what you would put in here, an 11. You'd have to offshoot it. 8 times 5 to the 11th. Oops. Okay. Alright, I did just go ahead and plop a 10 in our formula, and it did work. It's 0.0078125. So we're good. Yeah, that would work. Okay. We're going to go ahead. Oh, let me pause it real quick. Alright, we're going to call it a day. Do you know what your homework is? It's a quiz.
It's the back of the...
The back of last night. It's very good. So thanks for watching the video.